right. So I'll start. My name is Eyal, and I'm from Intel. I'm the Vice President and General Manager for the biometric segment. And I've been talking about speeding up security, utilizing facial recognition for access control. So usually every talk I start with a problem statement. And basically from my point of view, the problem statement is to make sure that we supply a solution that is transparent, secure, and private for biometric authentication, such that access control can utilize that technology to ease of, the use of the technology, basically to pass through the gate, to authenticate, and without any need to get the attention of the user. Basically, for the past couple of years, I would say that face is becoming your identity. Basically, it started with the plastic badges. It still is. There was an intermediate move to fingerprinting, and then basically face is taking over the entire segment. It's more secure, it's more reliable, and it's harder to basically attack in presentation attacks or any sort of attacks, and I'll explain that later on. I've tried to capture in one slide, there's too many usages that are being used now, but roughly, some of our customers are using it in vending machines, in preschools in California. Some of them are using it obviously in access control, in gate control. We got customers using it in ATMs, and that's just a small brief of the usages that is now being adopting the Face ID as the biometric solution for their current solutions. Maybe before I go deep into the technology, so give you some context in terms of what happened in the last decade and when it started ramping up, I would say in the last 4 to 5 years. So you can see from the graphs, the left-hand graph basically states one of the error rates that is being used in the LFW, the labeled face in the wild, very known database of faces. And you can see that basically it going down from 2, 3, 4% of error to the lower of 0.2, 0.3, and below in terms of error rate. And on the right-hand side, you can see basically some of the graphs from the NIST, the National Institute of Testing. And you can see that basically they've started with the visa tests, which is the blue line that started probably early 19 or probably even before. And once the error rate started to descend, then they started introducing new tests, like the mugshot, visa border, basically trying to get back to the error rate that is meaningful in order to really distinguish and differentiate between algorithms that are being submitted to that testing. So you can see as you come along the years from 2019 to roughly 2022, that's where basically the algorithms, the facial recognition algorithms, at least of the top, I would say the top tier algorithms in the market, became to some extent better than human, such that there was a need to introduce new tests that would make it hard and would be able to differentiate and classify how good your algorithm is. And maybe just one or two words on each one of them. So border is obviously taken from the United States Border Control, the database. It's a huge data set, obviously. Visa border is trying to compare between a visa image to a border. And there is a border by itself. It's kind of in the wild. Basically, when most of the people doesn't really look directly toward the camera, so you get a lot of tough images of people looking aside or some blurred images versus the visa or the mugshot. Mugshot is usually taken from people looking directly toward the camera. Many of them are from prison when they enter the prison, so these are more of the data set is constructed of. So it's a clear frontal image. So from one end, it's easy to sustain, but still over 90+% of the algorithms fail on these data sets. And maybe one word about fail. So when you get an accuracy of 90, 94%, 95%, one may think it's good enough for a product, but the algorithms for facial ID should go the 99 plus percent in order to really be used as a production-worthy product. So there's a handful of algorithms submitted for NIST, for example, that pass that criteria. Obviously, we are one of them. A little bit about our group. So our group started working on face recognition in 2014. Back then, it was the traditional computer vision techniques to identify, to detect a face, and then to infer from that the features, and then from that, basically to classify. Starting 2016, we started a transition to the AI world, to the neural network world. And basically, since then, we are developing the state-of-the-art solution in each one of the building blocks that I'll refer to in a second, from face detection, analysis, recognition, and anti-spoofing. I tried to mention the top two, I would say, building blocks that are relevant. One of them is data, or data, as my guys keep telling me. It's all about data acquisition, making sure the data is balanced, making sure the data is clean, making sure the data represents the real-world scenarios or the tests that you are submitting to. So there's a lot of work, years of work to get to the level of the data sets that we are using. And I'll go through that in a second. And the second one is obviously the generative AI and being able to produce synthetic data that augment your real data is also something that helped expedite basically the advance of the technology. So in a nutshell, face recognition pipeline, probably anyone that is doing it, goes through a detection phase where actually you detect the region of interest that you're going to work on that. One face, multiple faces, it's configurable, but detect a face. Then you got some analysis block. It's optional. We have it, and I'll explain what it is. On top of that, you have an anti-spoofing, basically classifying whether the person in the region of interest is a real person or it's kind of a presentation attack, spoof attack. Then you got the recognition, or what we call feature extraction, basically using AI, translating that face into a vector that represents that face. And then obviously comparing, searching the face and comparing to the database that you have to actually be able to return back whether it's a real face, this is the right person, not the right person, and with some confidence level. So I'll start digging in one click down, talking about our data. So just to give you guys number, and this is probably, if I would refresh, it probably keep increasing. So last I've created that deck, it was over 2 million faces that were marked annotated. So not just faces that were manually or automatically annotated. And facial landmarks, facial features, like 80 features, interesting features of your face, you can see on the right-hand side. Over 500,000 of these, which is a lot of work. It's over the years. You cannot just invest a lot of money and get it done. It's a lot of work because there's a lot of cleanup and there's a process that needs to go into that in order to make sure that you get a high quality data. Basically, generally speaking, it's in AI, it's a kind of a garbage in, garbage out. If you don't give it good data, you're not going to get what you need. So you need to make sure and keep sustaining the data cleaning and data productization. About the face recognition. So on the face recognition, we got more than 1.5 million unique identities for data that we've collected over a decade across the world, across the world, everywhere. We got data providers that are collecting data utilizing our specific process that uses specific lighting conditions, specific angles, distances, basically everything mimicking the real-world scenarios, utilizing our cameras to collect that data. And we are doing it across the world to make sure that we got a diverse data that we are using. On top of that, what I've mentioned earlier, we got a synthetic data generator, probably one of the best in the world. It's called 3DMM, 3D Morphological Model. Basically, it's been generated. We've created that simulator, I would say, utilizing 10,000 different people that were scanned in a high resolution. It's called 3DMD, the actual device that is used to scan. And then we ran algorithms to be able to parameterize every face in the world and then span it across, so we'll be able to generate, giving some parameters, any geometry and any texture that can generate faces at the end of the pipeline. Oh, I got artificial. So basically, that's one example. And you can see, by the way, it's across the world, that basically robustness is everything. Putting a face recognition out there, there are many of them. Also, passing up NIST, being the top 10 in the world in NIST, is a lot, but still it doesn't get you to a point where you can put your device in a mall in Dubai, as you can see down on the image, or you can put it in a complete dark environment, 0 lux, or you can put it in a roof in Asia that you can see, and still have it working. You need to make sure that you accommodate the overall solution to all of these specific environment or extreme environment, I would say, and still have it working in the same percentage that you are committed to in the spec. And we've invested a couple of years, I would say, along with our partners and with our customers to make sure that we reach that quality. I'll keep time at the end to questions. Face detection, one click down for each one of the building blocks. So there are multiple architectures that we've implemented for different power requirements. Basically, the two parameters that are being tracked for face detection is the precision and the recall. So we got about 99% recall, probably over that. It depends on the data set. That means we miss less than 1% of the faces, depending on the data set. And the precision is basically how accurate is the rectangle that you put around the face versus if it was automatically marked by, annotated by a real person. We support one or more than one face as an API call in our solution. And like I mentioned, it will go throughout the deck. We support all the lighting condition, backlight, side light, front light, everything basically. Another thing that we've learned over the years is that you need to be able to support all accessories, basically. Starting from the basic of COVID masks, sunglasses, but there are plenty of other accessories you wouldn't even think about and that might impact your accuracy. So you need to make sure that you support all accessories and do not degrade your precision. And obviously support all face angles, usually measured by your pitch, yaw, and roll. A little bit about face detection, the challenges. Face detection, there are two main challenges for everyone that is in that business. One is the scaling, because face can be closed, then you need to search for a bigger rectangle of the face, and the person can be farther away, then you need to search for a smaller portion of the face, so you need to take care of all of this scaling. And there are things for computer vision and AI, like the right-hand side, that looks like a face. And you need to make sure these are the false positives that you want to avoid. Because again, I'll keep repeating it, garbage in, garbage out. If you give a face recognition algorithm something that looks like that, you may get a vector on the other hand side that might fool your system. So you need to make sure that only the faces that you want to pass are passing to your continuous of the pipeline. Few words about the face analysis. So one of the techniques that we've used, and it was continued progress, is multitask networks, basically giving several tasks that has some correlation between them to basically get back results such as 2D or 3D landmarks and head orientation. For the 3D landmarks or the head orientation, we are using our 3DMM that I mentioned earlier. Otherwise, there is no way you can annotate in 3D an accurate head orientation or a 3D landmarks rather than having a good, high-quality synthetic data that you get it for free. Some more face attributes that we've recently introduced, COVID mask being an indication given to the application, and then basically the application can decide what they want to do with it. Depending on security level, they may want to ask the person to remove the COVID mask. They may want to ask the person to get the person to pass. Same for sunglasses. We are now starting to also generate age and gender that helps some of the use cases. And also give an alert whether the person is wearing a hat or a hoodie that hides some of the features that we are looking into. Head orientation, actually all these images that you see are 3D synthetic data that were generated by us. So we can generate any gender, any age, any head orientation, any expression in 3D. So we get the geometry and the texture from our 3D simulation. And then based on that, we get the 3D landmarks and we get the head orientation for free. The last portion of the pipeline is basically what we call the face recognition or the feature extractor. Basically, it's taking your face and I would say decoding a 512-dimensional sphere or a 512-dimensional vector that represents your face and is unique to your face across the world, across any other face, basically. And obviously, it cannot be reversed. You cannot take this 512 and regenerate the image of the face out of it. But it's uniquely identifying you versus anyone else. And the trick in AI and machine learning is basically taking this sphere and squeeze it as much as possible so it will, and then push it from other spheres of other people to make sure that you are uniquely identifying that person, but still capturing that person's appearances across all lighting conditions, all head orientations, all accessories, everything. So it's kind of a, I would say it's a forces, a game between loss functions to make sure that eventually you get the sphere small enough to be far away from other spheres that represents other people, but generic enough to include all of your appearances as part of this sphere. Some of the face recognition tests that we have, we got a huge test bench that we have in order to release a new face recognition model. Each one of them is using different testing technique. One of them is looking into frontal data sets for example, like the mugshot that I mentioned, and for use cases like ATM and cash banks. Some of them looks at large geo, where you want to go and have pass through a gate without having to look toward the camera. So it needs to deal with large geo, and there are many, many, many. We got over 30 different test benches that we test our algorithms before we have another release. One small example basically about face recognition and the threshold is basically based on all of the benchmarks. Eventually, we define a threshold that adheres to, for example, 1 to 1 million false positives, and on the other end, 99% or 98% true positive. This gives you a specific number, and the way it goes is if you are below that number, that means you're not the same person. If you are above that number, that means we return you are that person. And you can see pair of images basically, and what we call the confidence level or the threshold that marks whether we eventually return that it's the same person or not the same person. One of our latest works that we have done is taking the pair of images that algorithms find it tough to decide, kind of very close to the thresholds. Okay, it can be from that side or that side, and getting them to manual annotators to basically, using some voting techniques, to basically define or force our algorithms to say whether it's the same person or not the same person. And as you can see also throughout our submissions to NIST from the 007 to the latest submission, using that technique, we reduced the number of errors, or what we call similar subjects, by tens of percentage in terms of error rate, which is significant. It's basically, at the end of the day, you play with a 0.00001% in the NIST scoring, and in general, not only NIST scoring. Last thing about the face recognition itself is the fairness and ethical considerations. So basically, you need to make sure your data set well represents the population in terms of age, gender, ethnicities, basically making sure that we do not get anything saying, hey, it works less on, I don't know, whatever, ethnicity or age or gender. So we have clear definition, and we are tracking it as our data sets keep growing to make sure that we keep our training set and test set and validation set well balanced, to make sure that we adhere to these fairness and ethical considerations. All right. This is the fun part. This is the part I like. So basically, it's fun, but basically making sure that you got a solution that can stick around, wherever, in an ATM, in a place when there's no one looking at it, and making sure that nobody else can get your money out of the ATM. It needs to be great in face recognition, but it must have a very good anti-spoofing. Otherwise, I can take a picture of you from the internet. I can take a mask, create, I don't know, a $500 mask, a $100 mask, whatever it is, record the video, do anything, and fool the system if nobody is watching, and then basically get your money, get into your corporate through the gate, whatever it is. So we need to make sure that our technology or our product is bulletproof from that perspective. To do that, we've collected over, again, a decade, more than 10 million examples used for training and more than 4 million examples used for testing to make sure that we are balanced between training and testing. The attacks are basically anything. I have a paper of, I think, 60 different pages where we were certified in a lab in Europe, in Spain, and they were trying for 1 week, 5 people. They did crazy stuff, tried to attack it. We got a report saying, we got 0. And we are able, from the standard perspective, it was okay if they were able to hack us for 7%. We got 0. Basically, they couldn't hack it. And I'll explain in a second how we do it, from technical perspective. But just to put sense into it, we were not able to hack even once. And there are masks that have, this latex that, really it's a skin tone-like a material. So going again, one click down on that building block of the anti-spoofing. So we are using what is called multimodality. We just submitted a paper that we're going to present in a couple of weeks in Spain for the stereo modality, but each one of them is something that I'm treating as a lock. And in order for me to say that you are a real person, before you even approach my face recognition portion, you need to pass, depending on the security level, if I go to the highest security level, 5 different locks in order to pass all of these and then say, okay, this is a real person. Now face recognition, do feature extraction. Let's see if it is really Eyal or not. I'm using this. By the way, this is our device. So we're using the RealSense stereo techniques in order to basically detect what I call a geometry attacks. Basically understand whether whom is standing in front of me has the geometry of a face or any other geometry. It can be a flat paper, can be a curved paper, can be a cut paper, whatever. All of these are being eliminated by our AI model. Each one of these, by the way, is an AI model. Okay, it's a well-trained AI model. So the first one handles what we call the 2D attacks. That basically, by the way, these are the attacks that fails probably 99% of the current solutions because they are using a standard RGB. They're not using this type of stereo cameras. So any video recorded, blinking, all of that, can fool the system. On top of that, we are using what we call a vision model that utilizing the difference between the two characteristics of our sensors, and a trained model on top of that basically eliminates, I would say, the typical 3D masks, any Shrek masks, all of these masks that we've seen in Universal Studios and stuff like that, breaks, that this model, AI model, stops this. The third model, and there's like sub-models of this, but the third model is using the IR. We've got an IR LED that basically transmit specific wavelengths that we've learned, and based on that, we are able to eliminate whether it's a real person or not, so it kind of blocks, I would say, the more sophisticated 3D masks that looks more like skin tone, and looks more like the person, and have the curves and have everything, are blocked by this model. There are some, like I mentioned, there are 5, so there are 2 that are kind of combination of these that I not go into the details. What we did is basically generate, I would say, buy 3D masks, generate, I would say, 3D masks across the world, because there are masks that we bought in UK, in the US, in Asia, because each mask comes with a different, from a different material. So it's important not just if you go to 1 vendor, 2 vendors, 3 vendors, it will not give you the span that later on you will be able to reliably reject any of these attacks. And some of these we made sure that are also looking like our researchers or validation guys, so we'll be able to really test the whole pipeline. The second thing about, it's true for any AI technology, but it's especially true for anti-spoofing, is you need to make sure on one end to block, but that's easy. I can do like, return 0. That's easy, and block everyone. So you need to make sure that you also handle the true positive. You need to make sure that basically a real person doesn't get spoofed all the time or every once in a while, because then it's annoying, and then, it happened in some of the early stages of products that introduced anti-spoofing without naming names, and then it's tough to basically use that system, and you need to start punching your code, so it's annoying. So you need to make sure that the real-world scenarios, the real-life scenarios, are covered, and your true positive, your true negative, is basically making sure that you are blocking. There, on the security level high, we are 99.78 or something. But at the same time, you need to make sure your true positives are, I would say, above 97 or 98% to make it a real production worthy. And it's tough. The balance is very tough, very, very tough. And I've put here specifically images in the next slide as well that demonstrate why it's tough. It's tough because people have different appearances, so you can imagine it impacts the geometry of the face if you have a bird like me or like my friend here, or if you're wearing accessories, it changes your appearance, or any of these basically changes your appearance. And nevertheless, if you got COVID mask or you got other stuff, basically you need to make sure that you allow these people, of course, in specific security levels, you don't want to get a spoof because the mask created something that in terms of reflection doesn't look like a skin tone, or the head orientation doesn't give you the geometry because the geometry on the sidewise, it's not the same as the geometry on the front, and so on and so forth. There's many, 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 many other, I would call them data collection considerations that you need to take in order to get to where we are today in the 99.80 and 97 or 98 in the true positive. with all the world scenarios. So this is basically about the products that we have today. In a second, I'll also explain a little bit about the hardware that we see, but you can get the impression from the size of this device that basically is doing everything on the device. We don't go to the cloud to do processing. We don't go to any host connected to that to do processing. Basically, everything is done on the device, which is great, A, from cost. Our customer care about cost. B, from power. And I don't know if it's more important or less important, but privacy and security. Basically, no image leaves the device or doesn't need to leave the device. So you sustain the highest level of security that I am familiar in this area, utilizing a very small and low-power device. Going a little bit further, so the next thing that we will introduce, or we are introducing, obviously for gates, is tailgating. Basically, one of the things that a lot of our customers are asking, hey, we've installed your camera or your device in our gate. Now I want to make sure that nobody is tailgating, which is a known issue if you're in the gate business. So we are utilizing our technology. We've already started collecting a lot of data from very specific angles that can basically solve this problem and still keep the high level security for the face authentication on the same device. By the way, the same device. It's not another device. It's just another software feature on top of the same device that we are introducing basically to our customers. It's utilizing the latest vision language models to clean the data, to define what is really a tailgating and what is not a tailgating, how to define it as a safe zone. We're giving several options to our customers to define what is the interface. Either comes from the gate or we do it solely based on computer vision. All of this is coming as we speak. Maybe I'll say a few words about our solution in terms of software. So basically, the left-hand side is our device, and obviously, all is self-contained on that device. We provide, along with our device, also an SDK, such that you can connect to that device via a USB or UART, depending, and basically enable and run all of these APIs on that device. We've also introduced what we call a Dockerized solution that some of our customers are productizing, such that basically using REST API or any other remote API, basically, still being able to control our camera, our edge device, or any of our edge devices, maybe several edge devices. And on top of that, we have also encapsulated our technology into a library that also can be deployed and used by our customers in a handheld or mobile device if they want to do, for example, an enrollment using a phone, a mobile phone, and then authenticate utilizing our device. They can do that as well. And actually, that's the next slide. So again, the left top side is the standard way that everyone is using it today in a gate or whatever it is, that there is some host. It can be a low-power host. It can be any NUC, whatever it is, that connects to our device via USB or UART and enables the operation. We also enabled a library that is being integrated into a corporate mobile application, basically that they can be able to get all of the employees basically enrolled or using the mobile application, and also using our device for the access control itself. Like I mentioned, we also introduced a Docker solution. Basically, that means that big corporates, actually like Intel, if they want to make sure that now everyone is transitioning all of our gates to that device, they don't want to call out all the 80,000 employees to re-register using that device. They want to utilize a huge data set that they have for their own employees, the badges, and then automatically upload it to the Docker, get the signature, the 512 vector, and then transmit it to all of the devices, and then basically it's up and running without having the employee to do anything. And it's not just for Intel. There are other, basically the big corporates that we work with utilize that solution. The last one, which we just recently introduced, is also the ability to go to basically to a vendor or to a corporate or to any partner that already have an install base of cameras and just want to add our camera to a specific secure areas, but they want to have a one-stop shop. They want to have our solution utilized at their backend and should handle both their already installed cameras as well as our secure camera. So we enabled this one as well. Last slide, I would say technical slide, a little bit going one level down about our solution, our system, I would say. Is like I mentioned, we declare 1 to 1 million false positives with a 90, I don't know, 7, 8, or 9, depends on the data set, true positive. We got less than 1 second, a lot of less, actually less than half a second to get already the result back, get back the result to the host. And we're using the AES 256 plus other encryption techniques in order to make sure that also intrusion attack, for example, taking off the flash that saves the database of the users that are relevant to the camera, the dataset is encrypted and scrambled so nobody can actually infer from that. And nobody can tap. Basically, we passed all what we call in Intel the safe reviews to make sure that we launch the product in the security and access control area. So to summarize, I would say that your face is your ID. It's possible now due to what I've mentioned earlier. It's better than human accuracy. It's operating in real time. It's got a low power, low cost, so it's available everywhere. We see the explosion, really happening. It's available everywhere. And it's got the security and the privacy on-prem, basically on device, make it happen such that people feel less nervous that their images are going to the cloud. And I don't know if most important, but definitely within a year or two, you'll see that is the most important, having the best-in-class anti-spoofing to make sure that nobody can hack it. Nobody can hack it in any way. Nobody can steal your ID. Same as they can take your card if you drop it, or your credit card, or anything, basically. So this enables us basically to launch a product that we see the adoption rate, exponentially grow in various segments. And that's the thank you, and that's basically where our booth is in Hall D, I think, right? Yeah, in Hall D. If you want to drop by, and you'll see some of our partners are presenting their very cool gate control, boarding pass scanning, everything that is being done by utilizing our face technology. And actually, these 2 rewards we won with our partners on that behalf. That's it, guys. Thank you. I think I left 5 or 6 minutes for questions, if anyone has any question. Yeah, there's a mic if you need, though I can hear. If not, then I'll be happy if you guys can drop by our booth and get the impression of all these technologies that have been adapted our Face ID. Thank you.